Hello guys, my name is Emerson and today we will learn about the weight and exit system calls. So we will also learn about why do we use them, its implementation and how they work. So first of all, let's open our Linux operating system. So remember guys, why do we use Linux operating system for this kind of work? We use these because they give us control over the whole kernel. This gives us a great advantage for learning the OS. So let the machine restore. So guys, here we have our virtual machine. I have created a fork practice folder. As if you have seen the my previous video, you will get to know why I have created that and how did I do that. So let's create a file called fork.cpp. Let's open it, and here we will implement the concepts of wait system call and the other one is exit system call. So let's let me create the boilerplate. It is always a good practice to check if the program is running or not. So let's compile it and see if it is running or not. As you can see, we have no error. So first of all, I will tell you about the wait system call. For the wait system call to get implemented, we have to include two libraries. First one is system wait.h and the second one is hash include stdlib dot standard library. These two will help us to demonstrate the power of wait system call. So if you remember from a previous video that where we created integer PID, let's initialize it with 0 and we will call here the fork system call. What does the fork system call do? The fork system call creates a copy of the program itself and then run it all again concurrently. So let's write the if condition. If our PID is equal to -1, that means that the child has been failed. Next up, we have if PID is greater than or equal to 1, then we are in the parent process. Else you can see the dot condition. If you want that if the PID is 0, then we will see out that we are in the child process. So Let's see if it works or not. Then we will jump onto the implementation of wait system call. So let's run it and see if we have any errors or not. So as you can see, the parent process, we are in a parent process first and the child process is later on. So what if we want to run the child process first? Then obviously the parent will have to wait for it for the execution of child. So we will let wait is equal to null. Let's run it and see what will happen. So you can see we are in the child process and then we are in the parent process. So what happens here is that the program, when the fork is called, creates a two identical copies of itself. The first copy here, where the PID is equal to or greater than 1, here is a parent process and here you can consider it as a child process. These two runs concurrently. So this statement means that the parent will have to wait for the execution of child. So the child gets executed first. So what if we want to child wait for the execution of parent? So let's run it and see what will happen. We are in the child process first and we are in the parent process first. Sorry, I've just put it in the wrong place. Here we want the child to wait for the parent to be executed. Here you can see first we are in the parent process, then we are in the child process, which is totally opposite to this. We run it again. We are in the parent process and then we are in the child process. These are the implementation of wait system call. And for the exit system call, what the exit does, the exit just runs the concurrent copy running, which is running on the program. The concurrent running copy exits it. So exit with 0. What will happen when the parent will be executing? When the parent is done executing and we encounter this line, this will terminate the program and return 0. And if we are interested in getting the status of the wait, then we can initialize a status here and in status. Here I have to put status and I will let you show the status here. So let's run it and see what will happen. As you can see, the status is 0 because the parent has returned the 0. What if we make it 1? So let's see what will happen. As you can see, the status is already 0 because the 0 indicates the successful execution of a program or a copy of program. This variable here don't indicate that we will return this. This is passed for the another reasons. The reasons like what if we want, if we pass the function this, then what will be the answer of it. If we run it again, as you can see, the output gets changed. Another thing to mention is that we can write some things in here, and I want to demonstrate, I think, the lines before the wait in the child. Just take a minute and guess what will happen. If you are done guessing, then you can see if we compile it and run it, Lines before the child process. We are in the child process and then the parent process. Let's run it again and again and again. As you can see, we are in the parent process, then the child before the child process, then the child process. Okay, this indicates that, let me just keep it simple and remove the status thing. Let me just move this in here so you can see what does I mean by that. Now for the minute in the parent process. So here let's compile it and run it. You can see we are in the child's process, line before the parent process and then the parent process. You run it again and again and again. You can see our output is persistent. What happens then if we consider it the null? So let's run it again. Sorry, we have to compile it first and then run it again. As you can see, our output is persistent. So these are the methods where you can apply the wait and fork system calls, wait and exit system calls too, for the control of the program execution. So if you have any questions, you can ask it in the comment. So this is for it lesson. Thanks for watching.